A lot of my parents have been asking whether their students should be using calculators on their AoPS homework. They see their students getting frustrated with long division, multiplication, with lots of digits, and it's taking way too much time to complete their homework. So they want to know, is it okay to save a little bit of time and plug in numbers into a calculator? My answer is yes and no, but mostly no. Let's go into the textbooks to understand why. This is a problem from Chapter 1 of AoPS Pre-Algebra, where students are asked to add and subtract these large numbers. A naive solution would be to start with the first number and then add it to the second. Maybe they're showing their work off to the side, and then they go to the second pair of numbers and do the subtraction here. This very quickly gets pretty tedious and leaves you prone to making errors. So if your student is showing a lot of computation and you're wondering if there is some sort of trick or easier method to get to the solution without doing so much computation, a good source of information is the solutions manual. The solutions published by Art of Problem Solving are extremely detailed and well thought out. They give you the step-by-step instructions to solving the problem. For example, in this section of pre-algebra, students learn to rewrite subtraction as an addition. So a minus b is a plus the negation of b. This allows you to use the fact that addition is commutative and associative, which basically means that you can rearrange the terms at will. And if we look at all of our terms, we see that there are some terms that have numbers in common. We have a 268 and a minus 168, 1375 and a minus 1275. We'd really like to be able to pair these positive numbers at the front with the negative numbers in the back, and we can do that with our addition. This makes it much easier, and we've eliminated all of those ugly calculations. So don't skip the solution manual. They're available for the paper books. You have to buy them separately, and they are included in the electronic versions of the AoPS textbooks. Let's take a look at another example. This is a problem from Introduction to Algebra. Let's take a look here at Part B. Here we're instructed specifically to use the quadratic formula. Especially with beginner students, I like to write out the numbers that represent A, B, and C. And I like to write out the quadratic formula itself to help with memory. This makes it easier to plug in everything without making too many mistakes. We have negative b, that's positive 42. We have b squared, so I'll write it like this for now. This is a good habit to get into, by the way. When faced with squaring a large two-digit number like 42 that I don't have memorized, I hold back a bit because there might be a shortcut in my future. Let's go ahead and get this next term. This is minus 4 times a times c. That's a yikes. And then we'll take 2 times a, which is 18 in the denominator. This part under the square root worries me, so I'm looking for a shortcut. One thing that I noticed right away is that 42 is a multiple of 7. That's this first term. We've also got a 49, which is also a multiple of 7. I might be able to factor out a 7 from both of these terms. Also, 42 is even, so it's got a 2 in its prime factorization. When I square it, that's going to be a 4, and I'll be able to factor that perfect square out as well. Let's just take a look at under the square root sign. I'll rewrite it here, and I'll also note that the square of a negative number is the same as the square of a number. So I'll replace minus 42 squared with the positive square, and I'll rewrite 42 in its prime factorization. And I'll leave the second term the same, since it's already written as the product of 3 perfect squares. Now I'll go ahead and square out this, writing this as 2 squared, 3 squared, and 7 squared. And look at that. It turns out the terms under the square root sign resolve to 0. It can be difficult to hold back your students because they want to rush to calculate the solution. But as a parent or a teacher, if you can model looking for any common factors, especially under the square root sign, if they're perfect squares, you can see that there is a more clever solution. So now I've got a big 0 where the square root used to be, and then I just note that 42 is a multiple of 6, and so is 18, and our answer is 7 over 3. Let's take a look at one more example. This one is from AoPS Introduction to Counting and Probability. We want to find the largest factor that divides evenly into 5 factorial, 10 factorial, and 15 factorial. A naive solution would be to use the definition of factorial. It's not too bad with 5 factorial. Let's take a look at 10 factorial. The trouble with factorials, they get very large very quickly, and I'm not excited about having to multiply all of these terms. Nonetheless, many younger students will start multiplying this out, noting that this is 90, and then multiplying by 56, 96, maybe this is 120, and then we've got a 6 here, and they will persist, only to be rewarded with this 15 factorial, which will be even larger. If you're getting bogged down in calculations, it might be a good opportunity to see if there is a hint for this problem. And here it is. This may or may not be helpful to your student, but as always, a detailed solution is available to the student or the teacher in case your student is becoming frustrated. Let's take a quick look at how to find the greatest common factor of 5, 10, and 15 factorial. One of the lessons in this particular section is that we have a lot of common factors in the different factorials. So for example, we can rewrite 10 factorial as these 5 factors multiplied by 5 factorial. And the same thing with 15 factorial. 15 factorial are these 5 factorials multiplied by 10 factorial, which itself contains 5 factorial. So the answer to this problem is 5 factorial, and no calculations were needed. There will be some times in AoPS where you will need to use a calculator. Let's take a look at an example. This is again from AoPS, Introduction to Algebra, the section on interest rate problems. Here they call out specifically to feel free to use a calculator for the computations in this section. And indeed, these problems are fairly time-consuming unless you use a calculator, and there really is no shortcut. So take a look for instructions from AoPS. They will tell you when to use a calculator, but if you don't see an alert like this, then I would refrain from allowing your students to use one. Good luck with your AoPS homework. If you have any questions about the art of problem solving or math contests, please leave them in the comments.